Hello, I'm Philip Stoughton. I'm here on the Scoop Studio at Apex 2019. I'm joined by Arne from Creative Electron, Joel from Co-Young, and Michael from Aegis to talk about the topic of AI. What I really wanted to get to grips with, we talk a lot about AI, it's everywhere, seems to be going to take over our lives. Just as a side, my favorite keynote quote from CES was a guy from, I'm pretty sure it was Samsung, and in his keynote he said we should just give up making decisions and leave it to the computers because they're better at it than us. And I thought, I don't want that world. That's too scary. What I wanted to explore today is where can we get value from AI in the electronic manufacturing space. We're great at getting data. We've been talking a lot about how to push that data up into information, but how do we turn information into value? Can I start with you, Arne? I know you've been doing a lot of work. You brought some AI products to market recently.
Sure. Well, where we can utilize artificial intelligence is, I view it at this point as assisting the human beings into making better decisions and, also as a feedback loop, checking what's been decided or what's been analyzed to have that double cross-check, if you will, and ensure that what we have done as humans, is that the most efficient? Is that giving us good results? And if not, we have so much data, it's impossible as humans to consume and really digest that large quantity. So with AI, we're able to really capture the essence that's underlying all of this information.
Yeah, I think that's a really interesting way of looking at it. It's the ability to consume a huge amount of data, and it's the ability to augment the human operator. Joel, is that how you see it from a Co-Young point of view?
Well, without a doubt, that's absolutely the challenge. And again, we've talked about this many times, Phil. It's really about having the right kind of data and then having an engine that can process and analyze that data. I think ultimately what we're trying to do here is repurpose the human element for things that the human element is best designed to deal with, right? Let's go ahead and let the AI be applied where it can be. And in the process of doing that, we all become more efficient, right? The one commodity that we never have enough of is time, right? You can make money, you can lose money, you can make money again, but you can never get time back, right? So I think that's really what it's all about. If we can apply the artificial intelligence in a way that provides us with more time to do what we're wired to do, what we're designed to do, and what machines cannot do, then I think we've moved in the right direction.
Yeah, that makes sense. Michael, when you look at it from a point of view of, kind of from a MES point of view, you're looking at a lot of processes, a lot of different systems. Is the art of using AI picking where it should be? Because AI is quite narrow in its skill base, isn't it? You've got to pick something it can learn and it can understand.
Yeah, that's true. And the two companies here, I mean, you've both made some incredible developments in software that take the information that, in the past it was like you showed a human a picture and they would make a decision about something that's right or wrong, but the human could only conceive of so much information. And so even though they were clever, they had limited abilities. Now, the data that's coming from these machines, and I see you guys as being the drivers of Industry 4.0 because that's where the information comes from with which to make smart systems. But you're able to understand within a computer algorithm a lot more detail about what's been measured, about what's been seen. And so some of the algorithms that you apply in that software are non-human. They're things that a human wouldn't do because it's just not a human way of doing things. I think this has been an evolution of the software. At first we mimicked what the human would do, but now we've gone past that point and we're able to do more because we've got more data. So from our side, we at an MES level are representing the customer in a way that is a practical base for seeing what information is there and how to make use of it in many different ways. Because each of these great companies, they have the ability to use that data internally, and that's fine. But that very same data could also be used in many other applications that really go beyond the machine, the line, or even the factory. And so as we go along with the standards that both these companies have adopted, like Connected Factory Exchange, we are getting an access to that data that's never been seen before. And it's really exciting that not only can we get the data out, but we can also start to provide the data back more information about the product that will be tested, what components are on it, the differences, the minute variations in materials, for example, that were used. And so we can start to really work together now to create yet more intelligence within the software. Is that AI? I think it is. It is that first step of AI.
Yeah, and I think it's a really exciting step. And for me, and I've talked about this numerous times, it's the idea of this great domain knowledge. So in your case, in X-ray, in your case, visual inspection, automatic inspection, to be able to take that data and then do that higher level of data analysis and data fusion. You've already brought some products to market, parts counting, counterfeit detection. They're really interesting areas where AI adds value, but also that data would be, again, applicable elsewhere in the factory, I guess.
Yes, I think where, we have this line that we've set up for CFX, it's reporting information up to the cloud and there's a central location. Now, if that's being fed back to other systems that are part of that line, we're talking about let's do post-mortem analysis of our process and all of that, but in real time, if we're receiving this information, we're able to adapt and make changes in real time instead of having to suffer those consequences with the entire batch and then, realize at the end that our process had some faulty steps within that. We're able to make those corrections in real time. And I think that's where the real value of being connected, but also sharing this data with other systems as this larger ecosystem of CFX or some other, process communication.
Yeah, and just wanted to touch briefly on that thing of counterfeit detection. AI is one of those algorithms that, as you teach it things, it gets to the point where it's seen more than any number of people can have seen in a lifetime, and that's where it's really valuable in recognizing something that's out of the ordinary.
Oh, definitely. I mean, a human, like we're saying, even if we have those skills to recognize variances, differences, the amount of time that we're able to analyze and capture that data, it just doesn't compare to, a whole network of distributed computers that are, learning huge sets of data and then aggregating and collating all of that into, something that's a central algorithm.
Yeah, and central information. Joel, when you look at it from your point of view, you're looking at AI where it's used in your machine, you're looking at it in closed loops, and then you're kind of looking at the broader picture and where the data that you're producing is actually almost currency for the intelligence of the line. That's a number of steps, isn't it?
It is, and but I think you hit the nail on the head. It really is the currency. It's to feed an AI engine, you have to have that parametric data. It's very important, measurement-based, very concrete information. If we look at our KPO product, for example, we're utilizing machine learning and artificial intelligence to automatically come up with the recommended parameters for a given product for speed, pressure, and release on the screen printer, working with our partners. The end game in that is to take complete control of that process. So we set it up properly on the front end using artificial intelligence. We monitor it. We learn as we go using artificial intelligence. And then we make corrections automatically using artificial intelligence. Again, kind of comes back to what I said earlier. Now, the person that was standing there doing that, and to your point, the time it would take to set that up and to monitor it ongoing is now taken out of the equation. That person can do something else. Yeah. Likewise, further down the line, with the data we're receiving at AOI, all of that is crucial in providing feedback to every step of the process leading up to that point. So, yeah. Again, it's all about the currency. You're absolutely right. It really is, and having that true parametric data to feed to that engine to make those smart decisions is key.
Yeah, Michael, I was curious about what you said. I mean, I think when you look at those closed loops and those partnerships you see between equipment vendors where they're sharing data and using data to actuate and actually improve processes, that's really interesting. But at an MES level, you can perhaps even go further and spot instances where, maybe the inspection machine isn't really supposed to be influencing that machine, but actually there's something that it's doing that's impacting on placement, or something that inspection could be doing at an AOI level that's going to help X-ray. Is that kind of where you see that larger role?
There is a huge scope for that. Machines are extremely clever, but they are limited by what they can sense. Basically, it's like a human, what we can see and touch and feel, and then we can start to understand it. But if there are factors that we don't see, that we're not programmed to see, or we're focused on something and there's something else going on, those opportunities are lost. But as we're sharing information, and it's not just from the machines to the MES layer, it's machine to machine, machine to MES, MES back to the machine. We're all now connected. And so we have the ability to look at the longer view. Maybe that's something that exists on site as a kind of analysis of traceability information, or perhaps that's qualified standard messages we send up into a cloud where we can utilize some really serious computing power to start to put together factors that may be interacting together in a way that's unexpected. The real interest, though, is how do you do that? Because software has evolved from, when I was developing software, it was heuristic algorithms that were really mimicking how things should be done in an engineering sense. Then we went into things like genetic algorithms and simulated annealing and all kinds of stuff that's come since then, which represented a more random search for an answer, qualified by a measurement. How do we apply algorithms when we have so much data in the cloud? Because if you start looking for random answers in huge amounts of data, you will wait a huge amount of time, no matter how powerful a computer you've got. You have got to take with it some of the intelligence to create a kind of, it's not a heuristic algorithm, but it's an algorithm that, like a human, would be focused on a task, even though it's capable of focusing on many different tasks, but it's able to start to sort, like doing a jigsaw. You start sorting the pieces, these bits are the sky, these are the ground, and you start to then filter down and down and down until you get and put the solution together. So the kind of software that we see is a little bit different from what most people are expecting, I think. Yeah. And it's a new generation of software development. Maybe this is the kind of software that's driving our cars. And, they have big budgets to develop such kind of algorithms. But surely this kind of technology is also going to be fed into manufacturing.
Yeah.
So I think we're all going to be seeing a lot more of this now that we've standardized the way we exchange the data.
Yeah, and I think that's, sharing's the key. And I alluded to this in a previous conversation, but sharing's often a bit of a challenge in the industry, and these systems are going to learn more if they've got more data. So in some way we need to anonymize that data and be able to share it in a safe way. Is that something that you see as kind of, if you like, the next stage, where it's not just data on my line, it's data on all my factories and maybe all my competitors' factories?
Oh, definitely. I mean, in the area of machine learning, artificial intelligence, it requires a huge amount in order to get that model to really be robust. And, people are out there spending tons of money in order to purchase this data. So there's obviously a monetary value in that. And it is also proprietary, and maybe it contains something, that can be drawn from that may be risky for certain business entities to openly share that. So absolutely, if it could be, separated from being able to attach it to a specific entity, I think that would be useful and make it a lot more open for people to, be willing to share that.
Yeah, and I think what I see when I'm at shows like this, but also what I've seen uniquely in the last couple of years, and the CFX thing is a good example, is the vendors in this industry sharing. The vendors coming together and using their pieces of domain expertise and domain knowledge to create something that is for the greater good of the industry, and that's really encouraging. I think that'll help us get to the next stage. Arne, Joel, Michael, thank you so much for taking part. Thanks for being with us today, and we'll talk again soon. Thank you.